Okay, so there are a few things I want you to know and then a few things you need to know in order to do this lesson. So if f is a polynomial function, then we know some things. First, x equals a is a 0. I just wanted to just reiterate this. X equals a is a solution. X minus a is a factor. And a comma 0 is an x-intercept. And in this section, they're going to give us one of these forms, and we are going to be able to find the others if needed. So let's do another example, finding the zeros. Find all the real zeros. And relative extrema. Those two different things. So the first thing we'll do is find all the real zeros. So we have f of x equals negative 2x to the fourth plus 2x squared. So if we want to find the zeros, then f of x would be 0. So we'll replace that. The first thing you're going to do is look for your greatest common factor. They both have a factor of 2, and they both have at least x squared they can take out. If this leading coefficient is negative, then I want to factor the negative out with the 2. Factoring's like dividing. You divided the 2 out. 2 divided by 2 is just a 1. That's gone. X to the fourth divided by x squared is x squared. 2 divided by a negative 2 is a negative 1. And there was an x squared, but you took it away, so there's nothing left there. I'm going to rewrite that plus negative as just a minus. Now you check what's in the parentheses, and those parentheses will factor further. Those are a difference of squares. You have x and 1, and a plus and a minus. I love difference of squares. And so the real zeros are setting each of these factors equal to 0 and solving for x. If you have trouble with this, I just want you to reach out to me by text or email and let me try to help. So I get 0 equals x squared, and take the square root. Square root of 0 is 0. Over here we'll minus 1. We get negative 1 is x. Here we'll add 1. And we get 1 is x. So we got 3 zeros. And it said we would have at most 4. This 0 right here is important because it came from an x squared. So that was what we will call a repeated 0. There were actually 2 x's that gave us that answer. And that'll be important in a few minutes. To find the relative extrema, we're just going to put this in our graphing calculator and calculate, let's see, leading coefficients negative and degrees even. There's my phone. So if it's even and my leading coefficient's negative, it's going like that. So we're going to have a relative max. And we'll just calculate that on the calculator. Second calc, we'll put our function into y equals to help us to do that. So if you feel like you need more help with zeros, please just text me or email me, and texting me is the easiest. The next thing we want to talk about is if we have repeated zeros and what that means. It's a fantastic thing. I really love it. I'm going to refer to it a lot. Excuse me. For a polynomial function, a factor of x minus a to the k, where k is greater than 1, yields a repeated 0. Excuse me. I think I am coming down with something. Yields a repeated 0, x equals a, of multiplicity k. So it's just saying if you've got like x minus 3 to the 4th power. So I'm making a scenario for that. As long as k is a positive number greater than 1. Then we have a repeated 0. So this would give us, that's 4 x minus 3's, right? That's what that means. So there are 4 factors that are going to give me the same answer. So that's why it's a repeated 0. I'm not going to set each one of those equal to 0. I'm just going to say, then I'm going to get x equals 3 is 0. And it's going to have a multiplicity, fun word to say, multiplicity of 4. That means it was repeated 4 times, that same one. So if a multiplicity, if k is odd, so if you have a multiplicity that's an odd number, then my graph crosses at that 0. Crosses the x-axis at x equals a. So right then we just had a graph of x equals 3 was my last example. So I don't know what the graph looks like, but I know that at 3, where I get this 0, this x-intercept, it's going to cross through. If k is even, my graph touches, whoops, no either. And it also looks like it bounces, so it touches or it bounces at the 0, but doesn't cross. So for that example before with the 3, it actually had a multiplicity of 4. So maybe it comes down to the 3, it touches, and it bounces back up. So that's the difference, and you could tell by just looking at a graph. You would say, oh, there's an x-intercept right there at 3. It doesn't cross it, so it was a repeated 0. And I must have had more than, must have been an even root. And right here you look at it and you say, oh, crosses, so I must have had an odd number roots. So let's see how we're going to use all this information. You're just getting a lot of powerful tools to use. So we're going to find all the zeros of x to the 5th minus 3x to the 3rd minus x squared minus 4x minus 1. Actually, I don't love this. This one isn't factorable because we have 5 terms. So I think I may just pause the video right here. If we wanted to find all the zeros of this, we would just simply have to put that into our y equals and find them by looking at the graph. You could do second calc. Excuse me. I need to stop, don't I? You could do second calc 0 to locate the exact coordinate for each of those zeros. So we'll stop here for the day.